Hi everyone, today we're going to continue our analysis on this three-step cycle. So we've discussed part A, B, and C. Today we're going to talk about part D, where we need to calculate the net work for the entire cycle. So work net is just the work from process 1 to 2 plus work from 2 to 3 and plus the work from 3 to 1. Since the process 3 to 1 has constant volume, so this term goes to 0 because the work is just the pressure times the volume change. Since the volume change is 0, so the work is 0. So then we're left with work from 1 to 2 and work from 2 to 3. We already know the work from 1 to 2 because that's given in the problem. It's 10.5 kilojoules. So the only thing that we don't know in this case is just work from 2 to 3, and that's something that we're going to solve now. So work, as we said before, it's just pressure times dV. Right? And in this case, we're going to replace this P using ideal gas law with our P is mRT over V. The reason why we do that is because P in this case is not constant, so we want to replace this P with something that we know. So in this case we have mRT V dV. Right, and if you notice that we have these V's here, so these V's, they will stay inside of the integral, and mRT T2, because we're analyzing state 2 to 3, they will stay outside of the integral. So we have 1 over V dV from V2 to V3. Let me rewrite these because they're not very clear. V2, V3. Okay? But then you may wonder, hey, we don't know M, R, and T2. How are we going to solve this? But remember that we do know that P2, V2 is equal to M, R, T2. And P2 and V2, these are the values that we know. So we can replace mRT2 with P2 and V2 and then solve for our integral. Here the inverse, 1 over V, the integral of 1 over V is natural log V3 over V2. Now we know all the values, we just need to plug and chug. So P2 is 140,000 times V2, V2 is 0.103, and natural log of V3 is 0.028, and V2 is 0.103. And if we solve for that, we'll have negative 18782 joules. And that is, I'm going to make this a little thinner because I don't have enough space. So this is going to give us negative 18.782 kilojoule. Kilojoule. I'm going to write it here, kilojoule. Okay, so now we're just going to plug that number back into our equation here. Okay, so work from 1 to 2 is 10.5 kilojoule, and work from 2 to 3 is negative 18.782, and that gives us negative 8.282 kilojoule. And this is our final answer, so I'm going to box this. Alright? So now we're done with all the different steps, and I hope you find this video helpful, and thank you so much. Let me know if you have any questions or concerns. Thanks.